Hey guys, it's Miss Calgord. I'm here for lesson 12. We're going to work on exponents today. I just finished recording this one and had gray screen the whole time, but we're going to bounce back and make this a good one. All right, so go ahead and head to quizzes and enter code 9503092. Press pause on the video while you play the game. When you're done, press play and I'll go over one of those problems. All right, so let me put that pen. This problem I picked because it's similar to the exit ticket some of you guys have been struggling with. This expression here means 3 times the quantity 2x plus y plus 2y. So you have to multiply the 3 times each one of those values, okay? So it's like if I had that area model, right? The width there would be 3 because I'm multiplying all of those values by 3. So I have 2x plus y and plus 2y. 3 times 2x is 6x. 3 times y is 3y. 3 times 2y is 6y. There, okay? So there's a couple different expressions I can write to match this. I can write 6x plus 3y plus 6y. Sorry, my writing's a little bit messy. I'm not using my normal pen. Okay, and we see that right here, okay? The next thing I can do is I can do something called combining like terms. And that means I can take the values that have the same variable, 3y and 6y, and I can add them together. I cannot add 6x because it has an x instead of a y. It's not a like term, okay? If I add the 3y and the 6y, I would get 9y because 3 plus 6 is 9. And I would add that with the 6x, okay? So that would be this option here. I could not select 6x plus 2y, or 6x plus y plus 2y, because that would mean that I multiplied the 3 times the 2x, but not times the y or the 2y. So that one is not true. I also can't just add them all together. A 3 squished next to the parentheses like that is like a coefficient. That means multiplication, not addition. So you also can't choose this one. All right? Hopefully that helps. Pause the video here, jot down any of this that you would like to. When you're ready, press play. We'll move on and go over that exit ticket. All right, so the distributive property. So a couple of kids I saw gave me another expression here that was equivalent to 12 plus 4x, but they didn't use the distributive property. And mostly I saw expressions that were totally not equivalent here. So let's take a look at these numbers, 12 and 4x. I'm thinking, what are the factors there? I know that 3 times 4 is equal to 12. And I know that 4 times x is equal to 4x. I want to see if they have anything in common. And they both have a 4 there. If I'm thinking of a diagram, that would be my width, right? I'm multiplying that times something to get 12 plus 4x. And I know that 4 times 3 is 12, and 4 times x is the 4x there. To find that expression, I can think of it as multiplying that width by the quantity that's the length, right? And that would be 3 plus x. This would be similar to if I had like a thing I was finding the area of where I'm like multiplying like 3 times, let's say this whole length here, I have 4 plus 2. I know 4 plus 2 is 6, right? But let's say I didn't. 4 times 4 is 16. 4 times 2 is 12. And if it was 4 times 6, I know that would be so if I have 4 times 4 is 16, 4 times 2 is 8. If I add 16 plus 8, I would get 24, right? And that would be the same as the 6 times 4. So just kind of like some different ways to think about problems. Definitely don't give up on this skill. This is really important for 7th and 8th grade math. Jot down anything you want from this slide. When you're done, press play. We'll go over it. Or we'll move on. Okay. All right. So today we're going to see how exponents show repeated multiplication. And what I mean by that is we saw before, that repeated addition is the same thing as multiplication, right? So if I have 3 plus 3 plus 3, another way I can write that is 3 times 3 because there's 3 groups of 3. Now with exponents, I'm showing the number of 3's that are being multiplied by each other. So another way I could write this would be 3 squared, or 3 to the power of 2, or 3 to the second. A couple different ways we could say that. And we'll see more of that in today's lesson. So your goals for today are to evaluate expressions with exponents and write expressions with exponents that are equal to a given number, and to understand the meaning of an expression with an exponent like 3 to the power of 5. All right, so let's look at this notice and wonder. I just want you to pause here and think, what do you notice about this picture? Like, what are some patterns that you're noticing? Maybe what are the number of dots in each row? Just what do you notice about this? When you're ready to hear some things that I noticed, press play and we'll go over it. All right, so something that I noticed is that each time the number of dots here is like growing by 3. Each dot is kind of like generating 3 more dots. So I start off with 1 dot in that like black row there. Then I go to 3 in the red, right? And then each of those red dots splits off into 3 more dots. So then I have 3, 6, 9. Each of those green dots splits off again. And so I start to notice, that's like I'm multiplying by 3 each time. So I thought, 9 times 3 would be what? 27, right? So let's figure it out. I have 3, 6, 9, 12, 15, 18, 21, 24, 27. That pattern seems to work. So it would seem to reason that if I multiply 27 by 3, I would get 81, which would be the number of blue dots around the outside row. And if you don't believe me, you can pause here and count it for yourself. It's 81. All right. Let's move on. We'll come back to this picture later on. Okay, so let's talk about this genie's offer. I love this problem. Okay, so you find a brass bottle that looks really, really old. When you rub some dirt off the bottle, a genie appears. The genie offers you a reward. You must choose one. Either you can take $50,000 or take a magical $1 coin. The coin will turn into 2 coins on the first day. The 2 coins will turn into 4 coins on the second day. The 4 coins will double to 8 coins on the third day. The genie explains the doubling will continue for 28 days. So pause the video here and decide which one of these offers you are going to take. All right, hopefully you made up your mind. Let's see which offer was the best one to choose. So let's start off with these 2 problems here. I want you to pause this video and solve 1 and 2. When you're ready, we'll go over it. Press play. Number 1 says, the number of coins on the third day will be 2 times 2 times 2. Can you write another expression using exponents for the number of coins that will be on the third day? Number 2 says, what do 2 to the 5th and 2 to the 6th represent in this situation? Evaluate 2 to the 5th and 2 to the 6th without a calculator. All right, so let's start off with number 1 here. I'm looking at the number of coins will be 2 times 2 times 2. We talked about that I can use an exponent to show repeated multiplication. All right, I have 3 2's being multiplied by each other. So I can write this as 2 to the power of 3 or 2 to the third. I can say it either way. All right. If I wanted to evaluate it, 2 times 2 is 4. 4 times 2 is 8. So I know 2 to the third is equal to 8. What would 2 to the 5th and 2 to the 6th represent in this situation? Well, if on the third day, 2 to the third represents the number of coins, 2 to the 5th is the 5th day, and 2 to the 6th is the 6th day. Not that tricky of a genie. All right, so I want to figure out what 2 to the 5th is without using a calculator. So I would have 2 times 2 times 2 times 2 times 2. Do not write 2 times 5. 2 times 5 is 10. That is totally different than 2 to the power of 5, which means 5 2's multiplied by each other. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So I know that 2 to the 5th is equivalent to 32. All right, now what about 2 to the 6th? Well, here's the little trick. I know that 2 to the 5th is the same as, or 2 to the 6th, sorry, is the same as 2 to the 5th times another 2. Here's how I know that. So let's go ahead and write 2 to the 6th. All right, so I have 6 2's multiplied by each other. 1, 2, 3, 4, 5, 6. So what do you see here? The same thing, the same base. So I know this part here is equal to 32 times another 2, and that is 64. So 2 to the 6th is equal to 64. And you notice it basically doubles, right? So exponential growth is a way that things grow really, really quickly. So you might really be realizing now this Gini problem is not as straightforward as it initially seemed. So if you want to go back and change your choice, you should do it now. All right, jot down anything you want from this slide. When you're ready, press play. I'll erase it and we'll move on. Okay. So I want you to tackle these two problems as best you can on your own, and then we will find out the answer together. For number 3, I want you to solve for how many days would it take for the number of magical coins to exceed $50,000. And for number 4, will the value of the magical coins exceed $1 million within the 28 days? Explain or show your reasoning. All right, so before we actually solve these two problems, I want to take you through a simulation, and I'll attach the link to this to your agenda so you guys can check it out too. All right, so it has all the stuff that we've been doing, right? But let's take a look at this applet. Now this applet is going to represent the Gini problem here. So when I click play, we're going to see one coin, and on the first day it doubles, right? Okay. So we're seeing kind of like what we just talked about. And I'm going to go ahead and kind of draw a little table over here. So we see that we have like the day, and then let's have like an expression with the exponent and the value. Okay. All right. Sorry, this is a little messy. So on day 1, we end up doubling that coin initially, right? And so we call that like 2 to the 1st. And that's just like 2 times 2, or just 2 times itself, or not 2 times itself, sorry. Just 2 times nothing. And the value is 2. I have $2 on that first day. Sorry, I didn't explain that well. On day 2, we end up with 2 to the 2nd. 2 times 2. We see that right here. And that is 4. We can see even count the 4 coins. All right. So you might be noticing a little pattern here. And we talked about like what would happen on 2 to the 5th, 2 to the 6th, and so on and so on. So let's watch that simulation for a little bit and see kind of what happens. So day 10, you might notice, looks way different than days 1 and 2, right? This is probably way bigger than a lot of you thought this would get. So now we're on day 10. Ooh, I don't want to use purple. All right. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 2s. So that's the same as 2 to the power of 10 there. Okay. So if I was to multiply, that would be 2 times 2 times 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2, I have to think about that one. Is 128, I think? Yeah. 128. 1, 2, 3. 4. 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 2. 1, 2, 3. 4, 5, 6, 7, 8, right, so then 128 times 2, 16, carry the 1, 2 times 2 is 4, plus 1 is 5. That would add up as 256. 256 times 2, 6 times 2 is 12, carry the 1, 2 times 5 is 10, plus 1 is 11, carry the 1, 2 times 2 is 4, plus 1 is 5, 512. And then times 1 more 2, I'm already past 1,000. Whoa. Okay, 2 times 2 is 4, 2 times 1 is 2, and 2 times 5 is 10. So on day 10, I'm at $1,024 there. I know that it's going to double by the next day, right? So I'm seeing here this is going to go very, very, very quickly. So let's go ahead and watch this simulation, see what happens in a few days. Okay, so let's pause it at day 15. So we saw before at day 10, right? We had 1,024. Let me erase a little bit of space here. So at day 10, I had 1,024. So I had 2 to the 10th, but now I want 2 to the 15th. I'm going to use a different color. So I have 2 times 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ah! I ran out of space. 15. I'll add it on over here. Okay, so we can see these 2's, right, all line up. So I have 1, 2, 3, 4, 5. So I have 2 to the 10th times 2 times 2 times 2, 2 times 2, right? So I know that that's 1,024, right? And I can figure out what this is, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So I could take the 1,024 and multiply it by 32, and that would give me the value of 2 to the 10th. If you would like to use a calculator for this, I don't blame you. That's totally fine. I'm not going to ask you to evaluate this without a calculator right now. And we would get to 32,768. So by day 15, we're almost we're a little bit more than halfway through the experiment, right? Our exponent would be 2 to the 15th, and we're now at 32,768. Okay, what do you think would happen by day 16? We saw that between each day, we saw some doubling, right? To go from day 1 to 2, we doubled there. So I could take 2 to the 16th is equal to 2 to the 15th times 2. It's like 2 to the 1st, and I can add those exponents there. So I would take whatever 2 to the 15th is, which is 32,768, multiply it by 2, and that would give me 2 to the 16th there. And I'm expecting it's going to be about 64,000. I'm at 65,536 there. So yep, that's about what I was expecting, right? Okay, let's keep going with this applet and see what happens next. Stop at day 16. So this is where we got to. All right, so did we pass? Let me go back. Did we pass 50,000? Yeah, we did. It didn't even take the whole 28 days, right? So how many days did it take for it to pass 50,000? It would take 16 days. All right, will the value of the magical coins exceed $1 million? What do you think? Well, we can figure it out. So if I know it's going to double by the next day, right? And you can use a calculator to follow along with me here. That's totally fine. For day 17, up to the 17th, I'm going to take that 65,000 and I'm going to multiply it by 2 because I know that 2 to the 17th is equal to 2 to the 16th times 2. Okay? And I'll get 100. I'm going to erase this and give myself a little bit more space here. I didn't plan so well when I made these lines. All right. I'm going to be at 100 131,072. There? Okay. So now let me change colors so you can see the difference here. All right. I'm going to see day 18. So I'm looking at 2 to the 18th. And again, 2 to the 18th is equal to 2 to the 17th times 2. So I can double whatever I had the previous time. So if you're using the calculator, go ahead and multiply it by 2. And you should have gotten 262,144. All right, let's see day 19. Day 19 is going to take me past 500,000, right? Because I'm doubling that, 2 to the 19th. And again, 2 to the 19th is equal to 2 to the 18th times 2, right? So I can double that, and you should be at 524,288. And I predict, and hopefully you do too, that on day 20 is going to be the day we pass $1 million. I have 2 to the 20th because I know that 2 to the 20th is equal to 2 to the 19th times 2. I can multiply that times 2, and we pass $1 million. We're at 1,048,576. I recommend that you pause here and you take it all the way to 28 days and see how much money you would make by taking that Genie up on its offer. All right, you will be astounded. Okay, so go ahead and pause here, jot down anything you want. If you want to keep going with that, you totally can. When you're ready, press play and we'll move on. All right. So, will we exceed $1 million? Yes. We will exceed $1 million by day 20 because 2 to the 20th is equal to, what was it? 1,048,576. So we'll definitely pass it, and we will get way past that. Because remember, on the 21st day, it doubles again, so we're going to have over $2 million on the 21st day. Crazy. Wish I had this Genie offer in real life. Okay. Let's go ahead and move on. So you can try it out there. All right, so how did we know what 2 to the 5th represents and how could we evaluate it? We talked about this earlier, but I'll go over it one more time. So we know that 2 to the 5th means repeated multiplication of 2's 5 times. So 2 times 2 times 2 times 2 times 2. We would evaluate it by multiplying those 2's, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and we'd be left with 32 there. How many times greater than 2 to the 8th is then? How many times greater is 2 to the 8th than 2 to the 7th? So I know that 2 to the 8th is equal to 2 to the 7th times 2, because it's like 2 to the 1st, and I'm like adding those exponents. Could I answer this without evaluating both expressions? Yes, easily. Once I know the solution to 2 to the 7th, I would just multiply it by 2. I only have to evaluate one of them. Definitely makes it easier to use exponents because you can simplify your work a little bit more and not have to write like those such giant numbers. You can write them much smaller and reason about them more. We use the table to help us organize our work. And if you haven't yet, go ahead and check out how much money you would get at the end of the 28 days. It's definitely worth it. Okay, let's move on. Let's make 81. So what is an exponent? An exponent is used to indicate multiplying a number by itself. For example, 2 to the 4th means 2 times 2 times 2 times 2, so 2 to the 4th is equal to 16. There are different ways to say 2 to the 4th. You can say 2 raised to the power of 4, or 2 to the 4th power, or just 2 to the 4th. Okay, so I want you to go ahead and solve these. If you're ready, you can pause and just get to work. If you're not, keep listening. I'll read them to you. Here are some expressions. All but one of them equals 16. Find the one that is not equal to 16. Explain how you know. For part 2, write 3 expressions containing exponents so that each expression equals 81. All right. So looking at this first one here, I have 2 to the 3rd times 2. And I know that 2 to the 3rd is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. times one more 2 is going to be 16. So this one does equal 16. It can stay. 4 to the power of 2 means 4 times 4. 4 times 4 is 16. This one can also stay. This one might have been a little tricky for some of you guys. 2 to the 5th means 2 times 2 times 2 times 2 times 2 divided by 2. I can cancel out one of those 2. So I'm left with 2 to the 4th here. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I'd be left with 16 here as well. This can also stay. This was the tricky one, 8 to the power of 2. They wanted you to think of 8 times 2, but we know that 8 to the power of 2 means 8 times 8, and that's equal to 64. So hopefully you didn't get tricked. This one is not equal to 16. Okay. For part 2, we're writing 3 expressions containing exponents so that each one equals 81. So it's helpful to first break up that number 81. I think of 81 most often as 9 times 9. And I can split those 9s. So I could write 9 to the power of 2 because I have 2 9s that are being multiplied by each other. I could break up those 9s into 3s. And I would have 3 to the power of 4 because I have 4 3s all multiplied. That looks like 34. Yikes. Okay. So I have 3 to the power of 4 there. And that's 4 3s multiplied by each other. I could also use a combination. Here's what I mean by that. I could take these 2 3s. 3 times 3 and write 3 squared, or 3 to the power of 2, and then multiply it by the 9. I get 3 squared times 9. All those would equal 81. Go ahead and jot down anything you want from this screen. When you're ready, press play. We'll move on. All right. What if I wanted to try to write an expression that did not equal 81 but looked like an error in question 1? So what I bet a lot of you guys might have thought of is 9 to the power of 9, right? Because this looks kind of like 9 times 9 if you're not paying that close of attention, but this actually means 9 times 9 times 9 times 9 times 9 times 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be a huge number, right? That's not even close to 81. All right, let's move on. Okay, so let's go back to that dot pattern and see if we can write an expression to help us. So we start off with 1 times 3, right? And we ended up with, for this row here, it's kind of like that first day in the dot problem, right? Where it multiplied by 3. So looking here, I have 3, or 3 to the first, and that's equal to 3. Kind of like my first explosion there. Now for that next row here, I take that 3 and I multiply it by 3. And so I have 3 to the power of 2, which is equal to 3 times 3, which is equal to 9. I have 9 dots there, right? Then I multiply each of those by 3. So I have a 3 to the power of 3, which is equal to 3 times 3 times 3. And that is equal to, I'll draw around, 27. Now, for this last row here, and I can use what I've seen in the previous one here, right? As I know that 3 to the power of 3 is equal to 3 to the power of 2 times 3, right? For the last row here, I know that 3 to the power of 4 is equal to 3 to the power of 3 times 3. 3 to the third is 27 times 3 would be 81. So I know that 3 to the fourth is equal to 3 times 3 times 3 times 3, which is equal to 81. And if you still don't believe me, you're free to count there. So definitely remember that I can use other exponents to help me solve it. Like 3 to the fourth, I can use 3 to the third times 3 to help me solve a little bit more easily once I know what that is. All right, let's move on. Okay, so today's goals were to evaluate expressions with exponents and write expressions with exponents that are equal to a given number, and to understand the meaning of an expression with an exponent like 3 to the 5th. All right, so let's go into that cool down here. So it's telling you 3 to the 5th equals 243. And they're not asking you if it does, they're telling you. They're giving you a hint. Okay, they're telling you, yes, 3 to the 5th is equal to 243. Explain how to use that fact to quickly evaluate 3 to the 6. That means to find a value for, to solve for. They want a number, okay? So once you've solved this, you're going to come over to your exit ticket, press that plus sign to get a new slide. On the title, you can write your name. Make sure you write your name. I got a couple exit tickets last time with no name. Then to take a picture of your work, you go to the image and then click camera, okay? If you want to type your answer, that's fine too. Just make sure you give me that full solution. And again, please remember to do your own work and to show good effort on this. I'm giving you credit if you submit it. You don't have to get it right or wrong, but it's helpful for you to learn from your mistakes if you're doing your own authentic work after really participating in the lesson, okay? So happy solving, and I'll talk to you guys soon. Okay, bye.